Hello, I'm Shatavi Desai and my assignment is on a knowledge management system. And let's start. I've divided my assignment into two parts. Part 1 consists of primary learning styles, application development methodologies, and comparison and contrast of it, and using concept mapping. Part 2 consists of brain stimulation, benefits, risks, conclusion, and references. The primary learning styles are 7 types, and they are logical mathematical intelligence, linguistic intelligence, spatial, musical, kinesthetic, interpersonal, and intrapersonal intelligence. Coming to the logical mathematical intelligence, it is a type of intelligence that detects patterns, think logically, reason and analyze, and compute mathematical equations. For example, chemists, economists, and engineers. Linguistic intelligence is the mastery of oral and written language in self-expression and memory. For example, journalists, lawyers, and politicians. Spatial intelligence is the ability to recognize and manipulate patterns, large or small, in spatial relationships. For example, architects, pilots, sculptors. Musical intelligence is the ability to recognize and compose musical qualities, pitches and tones, and content, rhythm, and patterns for production and performance. For example, composers, conductors, and musicians. Kinesthetic intelligence is the ability to use the body or parts of the body to create products or solve problems, like athletes, dancers, surgeons. Interpersonal intelligence is the ability to recognize another's intentions and feelings, like managers, salespeople, and social workers. Intrapersonal intelligence is the ability to understand oneself and use the information to self-manage. For example, entrepreneurs and psychologists. Application development methodologies are agile methodologies, crystal method methodology, joint application development or JAD, and rapid application development or RAD, and waterfall methods. Agile software development is a conceptual framework for undertaking software engineering projects. There are a number of agile software development methods such as dynamic systems development method and Scrum. Agile methodologies emphasize real-time communication, preferably face-to-face, over written documents. Many agile teams are located in a bullpen and include the people necessary to finish the software. Coming to the Crystal methodology, it was developed by Alistair Cockburn, and his focus is on people, interaction, community, skills, talents, and communications, with the belief that these are what have the first order effect on performance. He says that the process is important, but it is secondary. Coming to the JAD, or Joint Application Development methodology, it is a requirements definition and user interface design methodology in which end users, executives, and developers attend intense off-site meetings to work out the system's details. JAD method aims to involve the client in the design and development of an application. It is accomplished through series of collaboration workshops, and they are called as JAD sessions. It focuses on business problems rather than technical skills, and it is mostly used in business systems development, and it can also be used in system software. RAD methodology, or Rapid Application Development, it is a general term which refers to any programming language that offers speedier implementation than traditional third-generation languages such as C, C++, Pascal, or Fortran. The rapid application development proposes that products can be developed faster and higher quality by using workshops or focus groups to gather requirements, or prototyping prototyping and user testing of designs, or reusing software components, or following a schedule that defers design improvements to the next product version, or keeping review meetings and other team communication informal. Coming to methodology. Waterfall methodology is also called as traditional methodology, and it is a popular version of the systems development lifecycle model for software engineering. It is often considered as the classic approach to the systems development lifecycle, and it describes development method that is rigid and linear. It has distinct goals for each phase of development, where each phase is completed for the next one before the next one is started, and there is no turning back. The advantage of waterfall process is that it allows departmentalization and managerial control. Coming to the concept map, I have divided into 4 different branches, which are supervised learning, unsupervised learning, primary and application development methodologies, as we have seen earlier. Now, coming to supervised learning. Supervised learning is where the algorithm generates a function that maps inputs into desired outputs. A standard formulation of the supervised learning task is the classification of a problem. The learner is required to learn a function which maps a vector into one of the several classes by looking at the input-output examples of a function. Unsupervised learning is a learning uh, which models a set of inputs, labeled examples, and labeled examples are not available. Supervised learning has been branched out into Bayesian methods, random forest, regression, neural networks, decision trees, support vector machines, and nearest neighbor methods. Unsupervised learning has been divided into 4 branches. One of them is clustering, which has been further branched out into k-means clustering and hierarchical clustering. Then we have Gaussian mixture models, self-organizing maps, and hidden Markov models, which are under supervised learning. And primary learning and application development methodologies have been discussed earlier, so I will continue to map each of them. I have mapped a couple of them to the which I felt was appropriate for it. So according to me, logical mathematical intelligence can be mapped to supervised learning, as supervised learning involves algorithms and functions, and logical mathematical intelligence also does. Coming to spatial intelligence, I have mapped this to application development methodologies, as this is also mostly it deals with lots of development and having chat sessions and class sessions. Similarly, I have also mapped it to clustering. Coming to the second part of my assignment, this is brain stimulation, and brain stimulation generates electrical impulses which affect targeted parts of brain using electrodes. It is used for treating neurological disorders, and more development is expected soon. Benefits of brain stimulation are: it is effective and safer than ablative surgical procedures. Ablative surgical procedures are surgical procedures during which tissue is removed, but in this it is not removed, so it is much safer than that. There are very few long-term complications compared to traditional surgery, because traditional surgery involves destroying small parts of the brain, while deep brain stimulation does not. Stimulator is adjusted to the needs of the patient, which means that this is pretty much flexible as per the needs of patient. And it is reversible, so if a patient does not feel comfortable with it, it can be reversed. So it is a reversible process. Coming to the risks of brain stimulation, the most important thing to keep in mind is there can be bleeding into the brain, and this can cause stroke. Although less than 1% of patients have experienced this. Now, the effects of stroke can be paralysis, loss of speech, coma, or even death. So, it's a very important thing to keep in mind before brain stimulation. There is less than 10% of chance of serious complications, and the less serious complications may be infection, malfunction, or of a stimulator and movement of the electrode or generator. And if any of these problems happen, it involves removal of the part or all of the brain stimulation system. So, luckily, it is reversible. These are my references, and thank you so much.